Okay, let's start a new chapter. Chapter 8, Section 1. We're going to have to divide Chapter 8, Section 1 into two parts because it's a fairly long section, and the second half of the section has some pretty heavy stuff in it. So we're going to just do the easy part today, save the other part for later. We will not be finishing this chapter, in case you're wondering. We're only going to do a couple sections, but we're going to do the most important sections. In fact, we're going to cover one of the most important things of the entire year before we're done. And there will be a mini test on the last day of school. Sorry. Okay, we're off. An equation in the form ax squared plus bx plus c equals 0 is the standard form of a quadratic equation. It's this ax squared thing right here that makes it quadratic. So there's your basic definition. Let's see, do I have an example here? Yes, here, no, that's not. Let's do an example here first. An example of a basic quadratic equation would be perhaps 5x squared minus 3x plus 2 equals 0, where a, in this case, is 5, and please be careful, b is not 3. b is, yeah, I hear you thinking it. Yes, I can hear you think. Scary, isn't it? b is negative 3, and c is 2. Hey, what if there is no c value? What if it looks like this? Now we would have a is 5, b is negative 3, and c is, in this case, 0. Or suppose we had this. In that case, a is 5, but b times x, there is no x in here. Ah, that means b is 0, and c is negative 3. Excuse me. All right, now, let's solve this guy. We've seen things like this before. This really is nothing new, not yet. It'll get new a little later on, especially in part 2. But this is nothing new. We're going to solve by factoring. What can I do to factor this thing? Oh, well, look, it's only two terms, and both terms contain an x. So how about if we take the x out? Factor out the x. And what are we left with? We're left with 3x plus 5. This lonely x out here tells you that one of your solutions is 0, because 0 times anything will be 0. But what does this part tell you? Remember what I call the glorious shortcut that I've never seen in any textbook? And I'm not going to review how the glorious shortcut works or where it comes from. It's not hard. But the glorious shortcut says all you do is change the sign and put negative 5 over 3. So x is also negative 5 thirds. Both of these answers, when plugged into the original equation, will work. Guaranteed. So we do indeed get two solutions, 0 and negative 5 thirds. As simple as this is, change the sign, put this over that. There were a number of you on that old chapter test who never quite caught on. Come on, you can do this. That's not hard. Notice in this particular case that a is 3, b is 5, and there is no c value, so that would be right here plus 0. C is oh, excuse me, is 0. And we move on to our next example. All right, this thing, there's a little trick we could use, but we're not going to. Some of you might be saying, hey, why don't we just divide both sides by x minus 1? We're not doing that. We're going to go ahead and multiply this out. Of course, this is really easy because we know that x minus 1 times x plus 1. We know how to do a minus b times a plus b. It's going to be a squared minus b squared. So we just have a squared minus b squared. On this side we have multiplied out 5x minus 5 I hope that by this time in your experience, your mathematical experience, you're not forgetting to distribute and multiply the 5 times -1. That's basic pre-algebra stuff. Okay, from there, because it's going to be quadratic, our best strategy here is going to be to get everything on the left side. So, we'll keep that x squared right where it is. Let's subtract 5x from both sides. And let's add 5 to both sides. -1 plus 5 being plus 4 equals 0. So our goal is to get 0 on one side. From there, we factor this thing. Ah yes, we haven't seen factoring in quite a while, have we? To factor it, it's FOIL backwards. I've sometimes referred to that as Leoff. FOIL backwards. We know that the firsts have to multiply to give x squared, so the firsts have to be x and x. We know the lasts have to multiply to give 4. It could be a 1 and a 4, or a 2 and a 2. We do know that the signs have to be the same because that's the only way two numbers can multiply to give a positive, is if either they are both pluses or they are both minuses. But wait a moment, they have to add to give a negative, so they must both be negatives. Now I need two things that multiply to give 4 but add to give -5. How about 1 and 4? And if we're unsure of ourselves, well, test it with FOIL. The firsts, of course, work. The outers, -4x. The inners, -1x. Put those together, -5x. And then the lasts, -1 times -4 is +4. There we have it. So what are our solutions? Our solutions are +1, or, by the way, I should use the word or x is +4. Why do we pick these two numbers? Because the question is, this is a review of something from a long time ago. If two things are multiplying to give 0, the only way two numbers can multiply to give 0 is if one of them is 0 or the other one is 0. What would it take for this to be a 0? If x were a 1. What would it take for this to be a 0? If x were a 4. So we get these two solutions. We get a solution of 1 and a solution of 4. Why do I put the word or in there? Simply because x can't be both at the same time. X can't be 1 and 4. It can be 1 or 4. It can't be 1 and 4 at the same time. That's why we use the word or. Oh, you mean I don't have to have both of those answers? No, you do have to have them both. They are both correct. They are both required. All right, another example. Did I skip something? No, I didn't. Okay. All right, let's solve x squared equals 9. Now this guy, although it is quadratic, x squared, this time there's a shortcut we can take. We don't have to get everything on the left side. If we take the square root of both sides, one might say, oh, we get x equals 3. But wait a moment. Doesn't this have two solutions? Let's face it. This will work if x is 3, but this will also work if x is -3. We get two solutions. Here's the rule. When we take the square root of both sides of an equation, we must consider both possibilities. So here's the rule. If you have an equation like x squared equals k, where k could be anything. If x squared equals k, when you take the square root of both sides, you must consider both the positive and the negative square root of k. And yes, you may use this plus or minus symbol. We read that plus or minus. Plus or minus. Plus or minus. Or you can listen separately if you want to. You can do that and say, or x is negative square root of k. You can do that if you want to, but why would you write all that if you can simply write plus or minus? So, quick example. If x squared is 9, We take the square root of both sides. We get x equals plus or minus the square root of 9, which is plus or minus 3. Done. That brings us to this example. In this case, we could factor it, but there is an easier way. Notice that in the general form, or the standard form of ax squared plus bx plus c equals 0, what is a? A is 3. B, there's no x value in here. That's because b is, here it comes, 0. C is negative 6. That's not b, that's c. Because b has to sit next to an x. There's no x in here, so b is 0. C is negative 6. We can write it out in standard form as 3x squared plus 0x minus 6. There's a, there's b, there's c. That's going to become extremely important later on. So in the special case when there is no b value, when b is 0, there's a shortcut we can take. Anytime b is 0, here's what you can do. Add 6 to both sides. Hey, let's divide by 3. Okay, divide by 3. And then take the square root of both sides. And what mistake did I just make? That's right. I have to make it plus or minus the square root of 2. That's vitally important. If you don't use the plus or minus, you're missing half of the correct answers and you're in trouble. That's it. We don't know what the square root of 2 is. It's irrational, so we stop there. I'm not, by the way, I'm not interested in your decimal approximations. Do not waste your time and energy and my time by plugging the square root of 2 into the calculator. I don't want your decimal approximations. I want your exact answer, which is plus or minus square root of 2. All right, let's do this guy. Let's use the same technique. Because there is no b value, a is 4, c is 9, there's no b. So let's just get the x squared by itself. That's another key, another clue here. If x is only in this one place, then just get it by itself. No factoring required. Back here, we couldn't do that. No, back, nope, back. Let's go back. Back here, we couldn't do that because x was in 2 places. We had to factor it. Even in this example right here, x was in 2 places. We couldn't get x by itself, we had to factor it. But in this example, x is in just 1 place. So we can just get it by itself. Likewise here, x is in just 1 place. There is no b value, so we can just get it by itself. Subtract 9. Let's divide by 4. And now, let's take the square root of both sides. We get x is, give me some space, okay. X is, watch out, we're taking the square root of both sides, so we must use plus or minus square root of negative 9/4. Wait just a minute. We can't do the square root of a negative. Well, the instructions here said to solve over the set of complex numbers, meaning we're allowed to use imaginary numbers. So what do? We pop its eye out. We pop out its eye, but also we take note, hey, I know the square root of 9/4. Isn't the square root of 9/4 just 3/2? So what do we get? We have plus or minus, we popped the I out, and we have 3/2. That's kind of awkward. We would normally put plus or minus 3/2 and put the I last. We treat it like it's variable. Variables always go on the end, so we write it that way, not the other way around. Remember, I is not a variable, but we kind of treat it like one. It would be really awkward to say plus or minus I times 3/2. That's just plain ugly. This is much higher class. So we took the square root of 9/4, which is 3/2. We didn't forget our plus or minus, and we popped the I out, and there it is. Meditate on that for a while, and you'll be fine. I'm going to try this one. This is actually not in the book, at least not in this section of the book. Let's solve this by factoring. Yes, I know we could subtract 9 and take the square root, plus or minus square root of negative 9. Pop the I out, we get plus, and take the square root of 9, we get plus or minus 3i. Okay, two answers, positive 3i and negative 3i. All right, but let's do it by factoring. Oh, but Mr. Bear, what? You can't factor a sum of squares. Well, no. I know we can't we can factor a difference of squares. X squared minus 9 would be what? X plus 3, x minus 3. Remember that old stuff? And remember how many times I reminded you that you cannot factor a sum of squares? But guess what? We can factor the sum of squares in the imaginary world. It's kind of like saying, yeah, in your imagination. Well, yeah. In the imaginary world, we can factor a sum of squares. Watch this. What if we try, instead of x plus 3 times x minus 3, which we know does not work, because this would give us x squared minus 9, how about if we do x plus 3i and x minus 3i? Now if we apply FOIL, firsts gives us x squared, outers gives us negative 3ix, inners gives us positive 3ix, they cancel. And the lasts, this is the beauty of it, the lasts gives us 3i times negative 3i would be minus 9i squared. But what's I squared? Oh yes, you should know this well by now. I squared is negative 1. That makes this whole thing turn into x squared plus 9. So we just successfully factored x squared plus 9. There it is. It acts just like a difference of squares, a plus b times a minus b, except we throw the i's in there, and that makes it a plus in the middle. That's so cool. Again, that's not in this section. I'm throwing it in there just kind of for fun. An introduction to future things. So if that's equal to 0, then what are my answers? Well, I get here, if I'm doing x plus 3i, I want that to be 0. So if only x were what? Negative 3i. Or if only x were positive 3i. Otherwise known as x is plus or minus 3i. The same thing we got by the other method. So sometimes with quadratic equations we get imaginary answers. And sometimes with quadratic equations we get real answers. And that's that. We're done for today. Because if I tried to push the second half of the section on you today, we would be doing this video for about an hour. So we cut it short today. And here's your assignment. 345 numbers 2 through 28 even. Now, it could be that some of you have some experience in some past math class. Some of you may know about this mysterious thing called the quadratic formula. Yes, we're going to be doing the quadratic formula, one of the greatest things in all of algebra. The quadratic formula is so cool. So if you know something about the quadratic formula, on these problems, do not use it. Do not use it. Because on the test, yes, there will be a test. On the test, there will be problems where you are required to use these other methods we've been talking about. And if you use the quadratic formula, then I will say, sorry, you didn't follow the instructions. But I got the right answer. But you didn't follow my instructions. So you need the practice in doing them this way, even if you know a different trick. So don't use that. All right, so if you know another way to do these, don't use it. You will be required to use today's methods on some of the test problems and must practice them. So that's it. I don't think I have anything on the next screen. No, I don't. So 345, 2 through 28 even. And next time we will do the great and famous and marvelous quadratic formula. See you then.